Okay, so talking about the answer to that real quick. So Java is a compiled language. If we go back to this little chart we drew last time, because we take the source code and we turn it into a low-level language. So go from a high-level language to a low-level language. All right, so that goes through a compiler, and with that regard, it's a compiled language. Now we have this thing called the Java virtual machine, which that's a piece of that's a computer written in software. And what that guy does is, at runtime, he translates from this low-level language into this other low-level language. So this is an interpreter. All right, so this is the interpreted aspect of Java. This is the compiled aspect of Java. So something, even if you just talked about it at the high level, but something towards that end is kind of what I was looking for. Java is both compiled and interpreted. Virtual machine interprets at runtime between the virtual computer and the real computer, something like that. All right, any questions on that concept? All right, so plugging along. We talked about when you might use assembly today, kind of if we have a certain part of a video game or something like that that needs to be really, really, really fast, and we're kind of at the mercy of what the compiler spits out. And sometimes our high-level languages today might limit us. We might have to write code in a certain way. We might have to ask a question when us as humans, we might know that the answer is always going to be yes or something like that. But Java is going to force us to ask that question, for example, or C# would force us to ask that question just because it doesn't know what we're thinking. It doesn't know about the problem we're necessarily solving. So in that situation, we might find it beneficial to go down to the assembly language level and doctor it up a little bit, change the output from that compiler so that that one part of our application is a little bit quicker. Now, generally speaking, probably not that big a deal. It's going to be some fraction of a microsecond difference in speed. Probably not going to notice. So we'll just go ahead and let the question be asked and move on with life. All right, so we started talking last time. These are a couple reminder slides, I assume, about I probably made this statement, Microsoft stole Java, but I didn't go much further than that, did I? Just kind of made that blanket statement. All right, so Microsoft's historical MO is that when they see a technology that they like, because our laws allow for this, a lot of times they'll go and take that technology, get sued, settle outside of court, and now Microsoft then applies their business model to that technology to get it out to the masses or change it a little bit and then get it out to the masses, whatever it is. Okay, this is kind of Microsoft's approach to things, and it's the approach of a lot of big companies. I think I've mentioned a few different times that I think Microsoft gets demonized for things where maybe it's just kind of a big fish in a fairly big pond, but they're the ones that make the news. So, so when they steal something, it makes the news. When some random developer down the street steals something, it meets gets in the off the blotter for the local paper or something like that. Okay, so Microsoft tried to steal Java. This was from Sun Microsystems. So Sun Microsystems sued Microsoft and won. All right, so long story short, Microsoft can't redistribute the Java language as their own, which is what they were trying to do. They added a language that Microsoft has a tool called Visual Studio, which we have on the machines down there. This is Microsoft's development suite. And Visual Studio is the type of animal this would be is something called an IDE, Integrated Developer Environment. So this is effectively a text editor on steroids. So you open it up and it's a specialized text editor specifically for doing programming stuff. All right, and as this Visual Studio supports several different Microsoft languages. So it supports Visual C++, Visual Basic, ASP.NET, C#. Our version might support Visual Fox Pro, but let's just say that's the extent there. Well, Microsoft back then added an additional language called J++, which was Java Microsoft style or something like that. All right, so it was effectively Java syntax, but running through Microsoft's runtime. So the idea was, how can we, maybe a weakness of Java historically has been that writing graphical user interface applications is more difficult than it should be. because Java's platform independent, and the way Windows puts stuff on the screen graphically is different than the way Apple puts stuff on the screen graphically, which is different than the way Linux puts stuff on the screen graphically. The common denominator across those three from a developer's perspective is more difficult. So we kind of have to generically describe our interfaces and then let each of those different platforms figure out what we meant. All right, so let's just generally say that writing graphical user interfaces in Java isn't that friendly. All right. Well, one of the things that Microsoft has always been very good at, and part of it's because the problem they're solving is easier, is Visual Studio has a nice what you see is what you get designer in it. You just drag buttons out there, drag labels out there, and everything looks perfect. Why? Well, because they're only targeting Windows. So they kind of know how their interface works and how things get presented on the screen. So that was a nice advantage. If you were already a fan of the Java syntax, so as we've kind of talked here, we're saying Java syntax is, let's call it the upgrade to C++, right? That doesn't mean it's always a benefit. There's an occasion where C++ actually gives us something that we would like to do. But in general, Java is a better tool, a power tool, compared to C++. So now if we like that language and we like working in that C++ language, but we're designing our applications primarily for Windows anyways, so just because Java's platform independent doesn't necessarily mean that we're always going to design platform independent applications. They just happen to be that way because you wrote it in Java, right? But if you're targeting Windows, which is a reasonable enough target since back in this time, 98% of the population ran Windows, why not use Microsoft's nice tool for creating a graphical user interface that actually functions and looks reasonable and stuff like that, and take that side of the problem and make it easier? Because designing GUIs with Visual Studio is fairly trivial, where designing GUIs using Java's tool set is not. Okay, the other end of the spectrum. So a lot of Java developers were fairly happy about this, right? But in any case, some microsystems sued them. They won, so Microsoft had to drop the J++ language from their suite of products. All right, so this is when Microsoft came out with a new language. Let's keep it on this slide, I guess. So this motivated Microsoft to create their own language with the same, well, let's just call it with similar advantages over C++ that Java had. All right, so can't use Java specifically, but you can certainly look at Java and say, okay, well, what do we like about Java? And can we write our own language that looks a lot like Java, since Java looks a lot like C++. We just can't use Java as is. That's what the lawsuit says. We can't just copy it. But we can make something that looks a lot like it. All right, so, and then they also said, well, okay, so that's the problem we're going to solve. Well, now that we have to spend the money and the time, other resources to actually solve this, is there anything we can do to improve Java? All right, so we've already talked about some of the weaknesses with Java, specifically this compiled versus interpreted thing, because that leads to slowness in the big scheme of things. All right, so C# versus Java. So we kept the, actually let me steal one of our older slides so I can just modify the differences. Yeah, let's just steal this one. Dump that, paste that. So let's say evolution of C#. So this really is the step from Java to C#. If you remember back from our picture we drew way back here, C# is slightly below Java. This guy came out after Java, but we're talking same ballpark of time period when these guys came out. All right, so we kept variables, we kept arrays, we kept classes. I'm actually not, there's something else I could say, but I'm not going to say it here. I think I'll just confuse the issue. So we're going to say we kept classes. We kept this idea of taking away a lot of those decisions from the programmer. So copy Java, just say it like that. Took many of the decisions away from the programmer and made these automatic. And also protected the programmer, but not necessarily through a virtual machine. And we'll talk about that here in a second. I'll actually just take the protected the programmer part off. They did, but in a completely different way. But what I'm going to say here is they added the ability to use pointers. What's a pointer again? Okay, so a variable, a variable that holds a value, and that value happens to be a memory address, so we say it points to that memory address. All right, so this added the ability to use pointers, because remember, Java took that away. All right, but it added the ability back in to use pointers, but only within an unsafe code block. So basically, C# says, look, if you really want to use pointers, we'll let you. But what you'll have to do is you'll have to prove to us that you know what you're doing by explicitly creating this unsafe part of your program. You know, unsafe, opening curly brace, closing curly brace, and put your dangerous stuff in there. All right, so at the very least, you're kind of saying, we get that we're manipulating memory and that could cause a problem. Trust me, I know what I'm doing. As such, I've agreed to mark this part of my program as unsafe. All right, so we're still sort of protecting the programmer from themselves, but we're also giving them that flexibility to still do some of this memory stuff. All right, so now what we want to do is we want to look at how C# accomplished, how it gets built compared to Java. So this goes back to this, was this slide right here. I'm going to steal that. So we're going to call this guy the .NET model. All right, because when C# came out, that's kind of the point in time when Microsoft introduced this idea of something called .NET. All right, so we're going to leave Java up here just as a comparison. All right, so now what we're going to say is we're going to take our C# source. So we're going to run this through a compiler. This is going to produce something called missile code, Microsoft Intermediate Language. That's a low-level language, basically equivalent to bytecode, just as this is Microsoft's version of bytecode. So we're identical at this point. All right, then we're going to run it through this virtual machine thing called the .NET, I'll just say .NET there, but it's actually called the .NET Component Architecture. All right, so we'll run it through Microsoft's virtual machine, which turns it into native assembly. Which ultimately runs on the CPU. Clearly, very, very, very different models. They've just changed the name of a few things. All right, but C# did do one thing that's important for us. One of the problems with Java, and this is related to today's quiz, is this idea of the interpreted aspect of it. The Java virtual machine, this is something that happens at runtime. Okay? While your Java program is actually executing, the virtual machine translates this Java bytecode into native code for that CPU, for that computer's CPU. So every single time you run your Java program, it gets interpreted. All right? Now with C#, when we feed our missile code to the .NET Component Architecture, this actually goes through something called a just-in-time compiler, JIT. Just-in-time compiler. And what a just-in-time compiler does, well, this happens prior to runtime. So we'll go ahead and we'll say just before runtime. Okay, so immediately before runtime, it's going to feed that missile code into that just-in-time compiler, which will produce native assembly before that program actually runs. And it's only going to do this the very first time this program runs, and then once every single time you actually make a modification to the program. But if you go ahead and get a video game, and sometimes you've probably had this on Windows where it says it must install the .NET component architecture for C# or something like that to run this game. You maybe have seen those things, or you just hit yes or next or whatever. What it's doing is it's installing the extra tools that it needs to do this type of thing. So the very first time you run that game on your computer, it'll run through that just-in-time compiler and ultimately produce permanent assembly code. So now every additional time you run that application, it's going to run natively. It's not going to go through this just-in-time compiler because it's already produced this native code that runs right on the CPU. So it's only interpreted the very first time you run it, and it happens actually before it actually runs. So it'll still run just as fast as it would if it was native. It'll just take a little bit longer to initially start because it's going through that just-in-time compiler. All right, so that seems to be an upgrade. Now remember, Java's claim to fame was write once, run anywhere, platform independence. C# says, well, you know what? We really like that about Java, because remember back then there was this perception that the Apple people were being mistreated because things didn't come out on their platform as quickly as it came out on Windows, and surely it should since they had 50% of the market, according to them. So C#, their claim to fame was this: we are also platform independent. All right, just like Java's platform independent because they ported the Java virtual machine over to every platform, Windows, Mac, Linux, whatever. .NET is platform independent on any platform that supports the .NET component architecture. All right. There's nothing that says that a C# program won't run on any computer as long as it supports the .NET architecture. Now, the interesting thing here is Microsoft is a proprietary company. They don't open source their stuff. So the issue is that Microsoft chose to only write the .NET component architecture for their own operating system. So this line could be translated to C# will run on any platform at all, as long as it's Windows. Okay, so whatever platform you have, it'll run as long as it's Windows. All right, so that's the C# way. But from a technology perspective, nothing keeps Microsoft from writing the .NET component architecture for the Mac or for Linux and having this program run on it. Okay, because it just has to understand how to convert missile code into native assembly for that. Okay, so it really follows the Java model, fixes the performance problem, and then gives Microsoft the option for who they want to be able to run applications written in that language. Okay. Now back then, Microsoft would have had very little motivation for porting the .NET component architecture over to another platform. Because even though the Apple people were saying that, oh, we have 50% of the market, every single statistic said that was not true. It said Microsoft had like 98% of the market. So their motivation for spending any dollars whatsoever making C# stuff work on the Mac was non-existent. Okay? So that's the C# language. Today, I think it would be, let's kind of just give a quick little overview of our, I usually call these the big three. So our big three languages today on the native side of things would be Java for writing apps that run on all platforms. So this probably right off the bat indicates not games. So this is really more of a business application type thing. C# for the Windows platform. And then Objective-C, more recently Swift for Mac. So these are our big three. If you're writing software that only is going to run on Windows, the tool to use is C#. Well, tool to use is Visual Studio. Their flagship language would be C#, but you can certainly work within C++ or Visual C++ or Visual Basic, or even the Visual Fox Pro or some of the other languages they have on there because of this. every single .NET language compiles down to missile code. So you can write part of your application in Visual Basic, part of it in C#, and part of it in Visual C++. They all compile down to missile code, which is identical, and then the .NET component architecture will interpret it right before runtime to turn it into native code. Now that's more of a parlor trick than anything else. So maybe in the early days of C#, there might have been certain things that would be easier to accomplish in a language like Visual Basic, maybe because it had been out longer, something like that. So maybe if you had a certain aspect of your application, you might say, well, I'm going to write this aspect in Visual Basic because I've already written it before, or something like that. Maybe you already have that piece and just want to integrate it into a new piece of software you're writing. But today, if you're writing a piece of software, it's going to be end-to-end C# on the Microsoft platform. If you're in the video game world, you probably are still working in C++ for some performance reasons. But actually, it's mostly convenience reasons, even though we can honestly say that C++ is maybe a more complex language to work within than C#, because so many of our video game things are already written in C++. So a lot of our game engines, which perform all the magical physics and things like that for our games, those are already written, and most of them are written in C++. All of our 3D libraries like OpenGL and DirectX, things that make 3D objects fly around on the screen, are written in C++. So you might as well speak the same language that those guys are already speaking in, which kind of drives why most of our modern video games are probably still written in C++. All right, but Microsoft's flagship development language today outside of the game industry would definitely be C#. Right, so if you're targeting Windows, you're going to write C# stuff. If you're targeting Mac, if you're starting a fresh project today, you'll use Swift. Otherwise, you'll use Objective-C if you're writing a project from that you've been working on for the last couple of years. And then for everything else, you kind of have Java. All right, so going back up to this picture up here, we've talked about C to C++, we talked about C++ to Java, now we talked about Java to C# and the differences here. So we go over to the Apple side of things. Back here, when we made the transition from C to C++, adding that object-orientedness to our programming languages, we had kind of a split, a difference in opinion, all right, where one side went to the C++ world, so this was Microsoft, and then Apple jumped on the Objective-C bandwagon because they didn't want to do the same thing as Microsoft. Okay? So realistically speaking, we can say that evolution of Objective-C basically the same as C++, used a slightly different syntax base. So C++ still looked pretty much identical to C. Objective-C took a little bit different approach. And just to give you a quick, just visual example of this, if you were building let's just say you were building a telephone object like we talked about here in class. If you were doing one of those in C++, you would say telephone pointer T equals new telephone, something like that. All right, so this is C++. In Objective-C, we would have said telephone pointer T is equal to telephone alloc init, something like that. So they use this square bracket type syntax rather than these parenthesis-based syntax. So the parenthesis thing was pretty much following C. And Java uses parentheses, C# uses parentheses. So all those languages in that lineage, C, C++, Java, C#, they all use the parenthesis-based thing. Objective-C took a little bit different approach. This is actually So we'll say Objective-C. This type of notation is usually called message passing notation. More of a trivia thing, not necessarily that important. I won't quiz you on that or anything, but that's what it would be called. We are sending the init message to whatever this guy is. And this guy is the piece of memory that was allocated by the operating system to hold one of these guys. And we're going to store that piece of memory in this variable named t, and that guy is of type telephone pointer. That's what that little asterisk means. So this is a variable capable of holding a memory address. What memory address does it hold? The memory address allocated by the operating system for this telephone. In C++, the new keyword does the same job of this guy. Go get me a memory address. Java has the new keyword. C# has the new keyword. In both of those, go get me a memory address. That's what it does. All right, so Objective-C just looked a little different. Part of that was Apple just likes being different. The other part of it is that that's what the other language looked like. That wasn't the one Microsoft was picking. Okay, so just quickly here, have I talked about? So I talked about that. Talked about programming languages. Okay, so we started on the native side. Sometimes I start on the web side. So let's go over here and talk. So now we're kind of sitting. Let's just say Objective-C 2.0 was just an upgrade to Objective-C. No major changes. They just tried to add some new libraries to bring themselves a little bit up to the same evolutionary standard that maybe Java and C# had, but it still looks like Objective-C. They didn't add or subtract any real language constructs. They just added some extra Apple libraries to it to help you make more Apple applications. All right, this really came out after Apple. Did we talk about Next computers or anything like that? Okay, so let's just talk about that real quick so we can kind of say where this came from. So Objective-C 2.0 came out after Apple acquired Next Computers. All right, anybody in here heard of Next Computers before? All right, tell me about what you know about Next.
Steve Jobs, probably the company that he made after himself, from Apple.
Okay.
Kind of burned and crashed because he made a computer that was super expensive and didn't do much.
Okay, so basically Next products all failed. Okay. All right. So punchline here. So what he said is mostly correct. So Apple got fired, or Steve Jobs got fired from Apple way back when, and so Steve Jobs was historically known for kind of being a lunatic. Hindsight, we can look at it and say, well, you got these people that changed the world of technology, certainly, to Steve Jobs, Bill Gates, and both of these guys are, let's say, marginally unstable to some level. Maybe it takes that kind of passion to change things the way they did. There was an autobiography, well, sort of an autobiography for Steve Jobs written near the end of his life that kind of talked about, as he maybe was addressing his humanity, when he kind of knew he was dying, but that all the things that he maybe regretted giving up, like he didn't think he was a good father and all this stuff, because he put so much into, his passion for the technology. So right or wrong, Steve Jobs was always considered to be kind of a difficult person to work for, because he was kind of a lunatic when it came to the technology and worked people crazy hours and that kind of stuff. Well, that passion eventually led him to be ousted from Apple. Even though he founded the company, it was a publicly traded company, so the board could kick him out. All right, so he still owned Apple stock or whatever, but he was no longer part of the day-to-day operations of the company. And the irony of this is this was after he approached the CEO of Pepsi the year before that. And it was kind of a famous quote where Steve Jobs says, "Do you want to change the world, or you want to sell sugar water the rest of your life?" So another one of these kind of famous quotey things. So the guy became the CEO of Apple, allowing Steve Jobs to focus on the Macintosh project. So internally at Apple, you had kind of an internal war. You had Apple, the Apple product that had been around forever and had done very well, and originally was running DOS, Microsoft's operating system. And at that point in time, Microsoft and Apple were actually partners, because Microsoft was, was providing their operating system for the Apple computers. So, when I was younger in my high school, we had Apple IIe computers that were running DOS, a Microsoft operating system. Well, internally at Apple, Steve Jobs wanted to focus on the Mac project, okay, which obviously history says kind of turned out okay, right? We don't buy Apple computers anymore, we buy Macs. Or we don't buy an Apple computer, we buy a Macintosh computer, I guess, is the punchline. But interesting kind of backstory with how that sort of went down is, so before, let's say before the Mac, but really there was a couple of other graphical user interface type things, all of our operating systems were text-based. They looked like DOS. They looked like this type of thing, where we would just type out here at the command line. All right, so that's what they looked like. That was our interface into the operating system. Have any of you ever used an operating system that way, where you didn't have any pictures or double-clicky on things? Everything was just through the keyboard? Half of a person? It's a little... Okay, so that's the way all computers were years ago. Steve Jobs, being more of a kind of a design-focused type thing, thought, hey, that's not the way computing should be. He was always forward-thinking, and that's fine. That's kind of, maybe what turned Apple into what Apple became. So he had some buddies over at Xerox. And Xerox, so this is in kind of the early days of personal computers. And the Xerox folks, they were dabbling with an operating system of their own that had a graphical user interface and a mouse, this thing with buttons on it and stuff. Yeah, those used to not exist either. You didn't need those when you were just typing everything on a screen, and double-clicking wasn't a thing. So, but what ended up happening is the Xerox team decided, you know what, I think we're going to abandon this project because the real money is in copy machines, okay, not in personal computers. So, Xerox has done all right for themselves, but maybe they would have done a little bit better if they had stuck with the personal computer bandwagon. Who knows? But in any case, they decided to abandon this project. So they had the Apple folks come in, meet with Xerox's engineers, and basically have the engineers tell Apple's people everything that they wanted to know about this operating system and stuff like that, effectively handing it to Apple. Okay, obviously, if you were an engineer working at Xerox, you would poured your life into this for the last year or something like that. That probably didn't make you that happy, but whatever, that's the way it went down. So internally, Apple created a second product line called the Macintosh that they were internally building as a competitor with so internally they created a competition within the company. They had the Apple folks and they had the Macintosh folks. The Apple folks was considered the product that was paying their bills. The Macintosh product was kind of a future-thinking thing and Steve Jobs is really passionate about it, and he wanted to go run that side of things. And they kept spending a bunch of money trying to do this stuff and research, and basically the Macintosh project internally at Apple became a drain on Apple's resources. Okay, so they wanted him to abandon the project and basically come back and let's focus on the Apple product. Well, Steve didn't do that. Long story short, he kicked out of the company. All right, so he gets fired. So in the meantime, a couple interesting things happened. First of all, at the time, Steve was a very wealthy person. It's not like Apple was a nothing company. In fact, back then, Apple was the big company. Kind of like what they became more recently. But they were considered the big company. He was a very wealthy person, and he came out of Apple, and he had a buddy at the time named, any of you heard of George Lucas? Who's George Lucas? It's the Star Wars guy, right? Okay, so George Lucas was going through an expensive divorce at the time, and he needed some cash. So he had a little company you've probably never heard of that he decided to He was wanting to sell, and he flipped it to Steve Jobs for, I think, something like $8 million or something like that. None of you have heard of Pixar before? You've heard of it? Yeah, I heard of Pixar. So little tiny company, not a big deal. Several blockbuster movies later, Pixar's worth some pretty good money, right? Steve Jobs, well, more recently than this historical story here, ended up selling Pixar to Disney for something like $7.5 billion. And he remained the head of the board, so he still ran the company. Kind of interesting story. But in any case, so Steve gets kicked out of Apple, buys Pixar on the cheap, let's say, and then goes and finds a company called Next. So this was Steve Jobs' approach, like, Apple screwed me over, so now I'm going to go and I'm going to rebuild my passion under this new computer called Next, this new computer company called Next. And Next's major kind of client group or customer base was education. So I think he pointed that out. So the real focus was, back then there was this incompatibility between Windows and Mac, much more so than we have today. To the point where if you put a floppy disk, like those, how many of you have never used a floppy disk? A couple of you? All right, so what about a real floppy disk? You had the 3.5-inch ones, which were kind of hard. They would be hard to bend in half. Then you had other ones that accidentally just bent in half, the 5.25-inch disc. Reminded me, I was watching an old rerun episode of Big Bang Theory last night, and Sheldon keeps his list of his mortal enemies on it. He's been building since he was 9 on a 5.25-inch floppy, so he has to bring out the extra drive to hook into his computer and all this stuff. But in any case, there was an incompatibility between the two, so Next Computer's focus was, let's build a computer that kind of has the best of both worlds and takes away this compatibility issue. As he pointed out, the problem was Next Computers were really expensive. Okay, really expensive. Now, that doesn't mean they didn't find their way into industry, because universities did buy them. Okay, so they actually were fairly popular computers within a very small group. And their operating system was considered to be a kind of a hit, certainly a move forward for technology. So Next did a lot of really cool things, but never really made it as a company on their own because Apple ended up acquiring them. So kind of talking about that story in the middle, during the dark years of Apple, so after Steve Jobs left, they thought Steve Jobs made things bad. Apple made a couple of business decisions that really almost led Apple to its failure. Anybody know what Apple did during that period of time that almost made Apple fail as a company? See, back then, it was kind of an interesting thing. The thing that people complained the most about Apple was probably what actually made Apple special. People would have complained back then that Apple was proprietary. Big complaint was that you had this compatibility issue. People who use PCs can't go over and use Macs because they would have to reformat their disks and all this stuff. And also Apples were, let's say, marginally more expensive. I don't think you quite had the difference that we have today, maybe. But they were considered very good quality machines, but they were considered very proprietary. And what that meant is if you wanted to modify your Mac, well, back then it was an Apple, you wanted to modify your Apple computer, you really had to go to like an Apple certified dealer who could get Apple specific parts at 3 times the price, and they could put it into the machine for you and all this stuff. So these were not things that the average enthusiast could kind of work with. And this was during a period of time where people started building their own computers. Personal computers became kind of a cool thing. Everybody was doing this stuff. So Apple gave in. And what they started doing is they started letting other companies create Macintosh. Well, in the meantime, after Steve Jobs was kicked out, they actually released Macintosh. So internally, that project kept going and finally turned out to be, oh, these are better than our Apple products. So it did transition over to Macintosh in there. But basically, there were places that were selling Macintosh clones. So you didn't have to buy your Macintosh computer, Macintosh compatible computer from Apple. You could buy it from 20 different companies. okay, at all sorts of different price points and things like that. Now, one of the things that we can look at today with Apple, and certainly something that this whole time period proved to us, is that generally speaking, when we hear the word proprietary, it has a negative connotation to us, right? We think proprietary equals maybe not the best idea in the world. But for some scenarios, proprietary actually equals maybe a better end user experience, a better product, something like that, because they're not having to play by this generic game across the board. Okay, so for instance, for car enthusiasts, we have our favorite cars that we might like driving, and we look at some of these new things like Teslas and stuff like that. Teslas are expensive, but they're not built like other cars. They're built with all sorts of other future thinking type things put into them. That doesn't mean they're better or worse, but they're certainly not following the normal standard of how a car is built, right? They're built with electric engines. Totally, the thought is in that direction. So the issue here is that the second you start trying to be compatible with everybody, you then become more generic. And that hurt Apple in that time period. So Apple really almost fails as a company, because now you've gone from having the people who are like, the Apple ultra fans. Apple can do no wrong. It doesn't matter how crappy the product is. It's perfect. Okay, this is well, to this day, that's the that's the Apple way, right? Apple releases anything, it's gold, even if it's crap. But now that Apple was just like everybody else, it kind of lost its shine. And now people are saying, well, why should I pay a premium for this product when I can get pretty much the same thing over here? Because half the Apple stuff isn't made by Apple anymore. So Apple basically fails as a company. Right before they failed, maybe internally they started regretting this idea that maybe we shouldn't have let Steve Jobs go. Yeah, the guy was a lunatic, but also he kind of was the heart of this company and kind of what made it Apple. Well, to save face, you can't just go back and rehire Steve Jobs. I mean, that's admitting defeat, right? They're a big company that would be bad for the shareholders. So instead, Apple purchased Next Computers, which came with Steve Jobs, because he was the CEO of Next Computers. So they purchased Next Computers, which came with Steve Jobs. So let's kind of throw a slide in here. Apple buys Next Computers. Purchase includes Steve Jobs. Added benefit. All right. Steve is then installed as the iCEO. Well, they originally called it the interim CEO, and then they eventually called him the iCEO. So he is the interim CEO of Apple. And then Steve Jobs starts, well, first of all, he pays Apple's payroll out of his own pocket for a little bit because the company was insolvent. They couldn't pay their own employees. So he keeps the company on its feet. And then he starts coming out with some pretty good products. So we have the iPod, the iMac, the iBook. The iBook was the before MacBooks. We had a thing. Remember the early iMacs? We actually have one out here. They were all the different colors. They named them after fruit. You had strawberry, orange, all that stuff. Well, the iBook was basically that colorful iMac in a laptop. Okay, that was called the iBook. Okay. Then he also, that then became, they once Apple kind of started becoming an enterprise powerhouse again, they kind of did away with that and said, laptop world is more of a business professionally type thing, so let's stick with the MacBook Pro type world thing. But basically, Steve Jobs comes out with a whole bunch of stuff with the letter I in front of it, and Apple goes from being a company in trouble to a company who was not in trouble, right? Made a lot of money. This particular guy here did pretty. Oh wait, we got to throw iPhone in there, right? Mildly successful. All right, so lots of I products in there. That's kind of when they started calling Steve Jobs the iCEO. Now, the issue here, and let me just kind of create our placeholder slide. So, what happened to Apple since this time period? None of us noticed, but Apple actually died. So we'll start by talking about that on Friday. We'll probably have another homework assignment on Friday as well. Don't get too used to not having assignments, because once we start doing the programming stuff, then you'll have assignments pretty often. But right now we're getting through a whole bunch of back stuff. All right, so we'll talk about how Apple actually died and none of us noticed next class.